Masses of atoms. Scientists have learned that protons and neutrons are made up of smaller particles called quarks. Inside these protons and neutrons, three quarks are moving at breakneck speeds that are bound together by something called a gluon, or the particle that carries a strong force. While you don't need to understand quarks and gluons yet, it is important to note that the energy of this interaction between quarks and gluons is what gives protons and neutrons their mass. The mass number of an atom is the sum of the number of protons and the number of neutrons in the nucleus of an atom. The number of protons in an atom is equal to the number called the atomic number. The atomic number identifies the element. In a neutral element, the number of protons equals the number of electrons because the positives balance out the negatives to make the element neutral. You can determine the number of neutrons in an atom if you remember that the mass number of an atom is the sum of the protons and neutrons in the nucleus. If you subtract the atomic number, or the number of protons, from the mass number, you would get the number of neutrons. Now, while atoms of the same element have the same number of protons, the number of neutrons can vary. Atoms of the same element that have different number of neutrons are called isotopes. For example, 4 out of 5 atoms of boron are boron 11, and 1 out of the 5 of borons is boron 10. The average atomic mass that you see on the periodic table is actually the average weight of all the isotopes of a single element. Looking at this chart, if I were to ask you what is the symbol of oxygen, you would say, oh, very good. Let's try another one. The atomic number is equal to the number of what? Correct, protons. How about this one? The number of neutrons is determined by subtracting which two numbers? Right again, subtracting the atomic number from the atomic mass or mass number equals the number of neutrons. Remember, in this chart, the average atomic mass is that of all the isotopes. So when we use the example of boron 10 and boron 11, you can see the average atomic mass is 10.81 AMUs, which is atomic mass unit. Okay, it's time to show what you know.